So we are going to talk about properties of rhombi and squares, first focusing on rhombi. A rhombi has the same properties of the parallelogram that we talked about last week before we did rectangles, and it has all those same properties that are listed here. Okay? And it has an additional 3 properties that says all four sides are congruent, the diagonals are perpendicular to each other. So not only do they bisect each other, as we did in parallelograms, but they are perpendicular to each other, meaning 90 degrees. So I wrote that in parentheses. And then diagonals bisect the opposite angles. So not only do they bisect each other, again, they bisect the angles that they go through. Okay? Now, it does not contain the parallel or the rectangle properties of having the diagonals being congruent or the 4 angles being right angles. It does not have those because these are just a rhombus. Okay. So we're going to start with this problem here. We know that JK is 12. And then we know that JN is 7. Okay. And we are asked to first find JM, okay, which is this. All right. Well, since it is a rhombus, if you go up here, it says all 4 sides are congruent. So if I come back down here, I know that actually all of these sides are 12, meaning that JM is 12. Okay. We are then asked to find JL, and JL is this entire segment here. And we know that diagonals are bisected. So if JN is 7, then NL also has to be 7. So if I put those 2 sections together, it gives me the full length of that diagonal as 14. MN is this section here that we are trying to find. And if you notice, we did say that diagonals are perpendicular, so that means that's a right angle. We have a right triangle. So we're going to use Pythagorean theorem to find MN. If you have 2 of 3 sides of a right triangle, you can use Pythagorean theorem. Pythagorean theorem says I'm going to square my 2 legs and add them and equal to the hypotenuse. So I'm going to have a squared, which will be my variable, or let's just call it x. So I'll let this be x. Plus 7 squared, the other leg. Again, the legs are the ones that are attached to the right angle. So you see the x is touching the right angle and the 7 is touching the right angle, equal to 12 squared, which is opposite the right angle. The hypotenuse is the longest side. I'll go ahead and simplify so that I can begin to solve this. I'll subtract 49 from both sides so that I have x squared is equal to 95. And then I'll square root both sides, and I'll get approximately 9.7. Okay, that's what I have there. Right. So this is not x anymore. It is 9.7. Right. Now it asks for MK, which is this entire diagonal. So if that part is 9.7, then this part is 9.7 because diagonals bisect each other. So I will do 9.7 plus 9.7 to get MK. So I will get 19.4. Moving on to the next example, we have EF is 23, which means all of these sides are 23 because it's a rhombus. So I'm going to go ahead and fill that in just in case it becomes useful. And I know that DF, this entire segment here, I know it's 40. Okay, so just in case that's useful, go ahead and mark it down. And just remember that that's a right angle. That also might be helpful. So GF is what we're first going to look for. And GF is this, and we already said it's 23 because all the sides of a rhombus are equal, 23. All right, then we're going to look at HF, and HF is this part right here. If you notice, it's part of that diagonal that's 40, and diagonals bisect each other. So I can do 40 divided by 2, and I will get 20 for HF. Then I'm going to be looking for GH, which is this segment here. Okay, so I have this as 20, I have this as 23, and I am looking for this. So I will let that be X. Okay, and again, that's a right triangle, and we have 2 or 3 sides, so we're going to use Pythagorean theorem. So I'm going to take the 2 sides that are attached or adjacent to the right angle, and I'm going to square them. Those are your legs. And then I'll equal it after I add them to the hypotenuse, which is opposite the right angle, opposite meaning not touching it, 23 squared. And I'll go ahead and simplify that. And I'll subtract 400 from both sides, square root both sides, and I'll get x is approximately 11.4. Why don't we just round to the nearest tenth? Okay. GE is, so that was GH. So here is 11.4, meaning this is also 11.4. So if I'm looking now for GE, I'm going to add 11.4 plus 11.4, giving me 22.8. Moving on down to number 3. We have RT is 22, and US is the other diagonal, and is 18. Okay, so we have those 2 measures, which means that, again, we have this right angle, but that each of the sections for the diagonals are split in 2. So this is, if this RT is 22, this part is 11, and this part is 11. If that US is 18, this part is 9, this part is 9. How did I get that? I did 11, or I did 22 divided by 2 to get 11, and I did 18 divided by 2 to get 9, because that's what a bisecting means, is cutting in equal parts, and those diagonals bisect each other. Now we're looking for VT, and VT we just decided was 11 because we did the entire RT divided by 2. UV we calculated to be 9 because we did the entire diagonal 18 divided by 2. Now RS, I'm going to erase these parts here that I don't need right now. RS is this diagonal here, okay, which is part of this right triangle. And I know 2 of the 3 sides of this right triangle is 11 and 9. Now, benefit to this, we don't have to do the subtraction we did before, because I know the 2 legs, the 2 sides attached. I know them, so they'll be together equal to x squared. And so we'll let this hypotenuse be x. So I will simplify. Square root both sides after you get them added, and I'll get x is approximately 14.2. Then it's asking for xt, which is another side. So if this side is 14.2, so is every side, because it's a rhombus. Number 4, we're just going to look at angles now, where we were looking at segments. Okay, so we have 38 degrees, and that's the only piece of information they gave us, except for the fact this is a rhombus. So if I work my way around, I'll be able to find different pieces. So if I know that this is 38, then this also has to be 38, because the angles have been bisected and opposite angles are equal. So this is 38 and this is 38. Okay, very, very helpful. What we also know is that consecutive angles, these 2 entire angles, add to 180. So if I subtract both of those 38s away, I get 104. And that means this entire angle is 104. But again, these 2 are equal, so I need to split it equally 2 ways. So I will do 104 divided by 2 so that I get 52 for both of these angles, meaning I have now found angle 1 and angle 2, because those angles are bisected. Angle 3 we already found as 38 because the angles are bisected. Angle 4, using alternate interior angles or opposite angles being equal, is 38, as is 35. Okay. And then measure of angle 6 is going to be opposite interior angles. with that 52, so it's also 52 degrees. And then angle 8, if you remember that diagonals are perpendicular, means that this is 90 degrees. Go on to the last problem here. We have ZY as 34. We have WX or WY as 38. So this whole thing is 38. And we have ZXY as 34. 1/5 u to the 5th. You're increasing the power by 1, dividing by that power, plus c, equal to, and what's my final answer? Plus c. Very good. Whatever you do, don't forget that plus c.
Where did we use the 3dx?
We use the 3dx. See how I circled here the 3 and the dx? And that's equivalent to du. So when we plugged in this du here, that's where that happened at.
Okay, we don't really like just plug it in for anything.
No, we did substitution. So in place of 3dx, it became du. Even though they're separated, remember that multiplication is commutative. You can rearrange those any way you want within the multiplication. Like I can't get inside the parentheses, but I can still rearrange the parts of the product. Anyway, so that 3 and du together make up, or 3 and dx together make up the du. Good question. All right, a little harder-ish. Well, it's not really that too bad. All right, here's the thing. If you pick a u and it doesn't work out to substitute at all, like you can't figure it out, maybe pick a different u. Okay, I'm just going to throw that out there because this next one, I feel like you can kind of look and like, they're not very different. You might pick the wrong one to start, but then you should quickly realize that it's not going to work out. All right, so on B, it is a composition because it's a product, and I guess you could distribute it if you wanted to, but it also works with U substitution better. We'll call this method U substitution, actually. In some textbooks, that's actually what it's called. All right, so we're going to let U equal, any guesses? The second one. What made you think that, Emilio? Because you're right. Because if you notice, if I just kind of picture, if I'm deriving that one, I have an extra variable, which would then result in the one written before it. So I'm going to let u equal e to the x plus 1, so that my du is equal to, well, the derivative of e to the x is e to the x, and my derivative of x is just 1 dx. So
Chase Bachowski, please come to the office.
So this guy will replace with u, and these two things together will replace with du. Okay. So then what will this integral be? Anyone brave enough?
U du.
It is u du. Awesome. So the antiderivative of u is
1/2 u squared.
1/2 u squared plus c equals 1/2. Replace u with what u is equal to, which is that ex to e to the x plus x plus c squared. So even though it didn't really look super composite before, if you look, it is part of what was a composite function. The problem with if you would have distributed this out, you would have had a really hard time anti-deriving it. But you would realize that quickly if you did it, because you're going to have a hard time doing the antiderivative. Well, no, it wouldn't. You just have more u substitution. You have to u substitute several different sections of it is what you'd have to do with what you distributed. Okay, let's look at C. Let u equal what? X cubed minus 2, perfect. Du is going to be 3x squared dx. So if you notice, that's my u, and that together is my du. Good? So what is this antiderivative when I rewrite it? Any ideas? If you look at the part that we're not substituting in for, it's the square root. So the square root will still remain. And then we're replacing what's inside the square root with u. So we have this. Which actually, here's the thing. If I were doing this problem on my own, I wouldn't even write that. I would write 1/2, exactly. That's what I would do. I would automatically go from one to the other without doing so many steps. But it depends on your brain. And if you need to see that, then you should write that down. And it's not a big deal. Okay, so then we do the antiderivative of that. It's not as pretty as before, but we'll increase the power by 1 and then divide by that. Keeping in mind, when you divide by a fraction, it's the same as multiplying by the reciprocal. All right, so what is the antiderivative of u to the 1/2? Very good. 2/3 u to the 3/2 plus c. So I increase power by 1 divided by 3/2, which means I multiply by 2/3. Then I'm going to go ahead and plug in my function. And I will have 2/3 x cubed minus 2 to the 3/2 and plus c. Okay. All right. Let u equal
1 minus 2x squared.
very good. 1 minus 2x squared. So then du is equal to,
Negative 4x.
well, yep, negative 4x dx, good. And it's not equal to negative 4x dx because the numerator is equal to negative 4x dx. It's negative 4x dx because we took the derivative of 1 minus 2x squared. Good. And it matches perfect. So we're all in candy lane here. And we'll go ahead and distribute it. Yes, ma'am.
Will the du typically be?
It'll be so close.
Yeah.
Like if it's not exact, it'll be like, well, I just need to multiply by 2 or I just need to divide by 2, something like that. If it's not close at all, like you have way more x's or something, you're probably not using this method. You probably need to do something else. Okay. But they shouldn't be mixing them. Like if you're doing homework in this section, you're going to be doing u substitution. All right. So then I will have, I just want to see if anybody can do this. When I plug it back in, what does it look like? Oh, gosh, why are you so smart, Emilio? Okay, so it is 1 over u squared du. Do you see that, how it would be that? And he went ahead and saved us some time by go ahead and moving it up so we can do our derivative. So it is u to the negative 2 du. Okay, because we substituted this whole thing became du, which means you could technically have a du on the numerator, or you could do 1 and then a du outside of it. And then the denominator was u squared. So then in moving it up, it became negative. Okay. Integrating that, we get increase the power by 1, divide by that power. What do you get? Negative 1 over u. Good. Because you're going to have u to the negative 1 multiplied by negative 1. And then Alexis went ahead and saved us some time and rewrote it. Don't forget your plus c. All right. Equal to negative 1 over 1 minus 2x squared plus c. All right, I'm going to pause real quick because I have left something really important out, and it doesn't change anything we've done, but it does change, like, concept-wise, something we might do in the future. You see how we have plus c and we have u's, and you see how we have plus c and we have x's? Those would technically be different values. They're different constants. Okay. Now, it's still a constant that we don't know, and it's still a constant we don't know. But in an actual situation, if you knew your limits of integration, they would be very different numbers. Okay, so just keep that in mind. They are different constants because we'll get to a point where it matters that they're different constants. Okay, so just keep in mind, we're changing one constant to another constant and still calling it a constant. And it's okay because they're still both mystery constants, but just they're different. And a lot of times in text, they'll do this, where they call them different constants. Okay, or they'll just do one of them has a subscript and the other one doesn't. Okay. All right, last one on this slide. Let u equal, picture how it would be rewritten. What do you think? What is u going to be?
Cosine x.
Cosine x, because that whole cosine x is squared. Even though they write it cosine squared x, that is the same thing as cosine x in parentheses squared. Okay, so then du is the derivative of cosine x, or the differential of cosine x. It's negative sign. However, no negative, where I need to substitute in for. This, in not the squared itself, is my u. This is what I need to substitute in for, and it has to match identical. How am I going to make it match? Divide both sides by negative 1. Okay, or multiply both sides by -1. Or just change both side signs. Okay, either way, you got to keep it balanced. So now it substitutes in perfectly. So in place of that, I'm going to be substituting in negative du. So then what would this integral look like?
U squared minus du.
So don't do minus du, because again, this is all multiplied. It would be either times negative du, or since that's the same thing as a -1 being multiplied, I can actually pull that negative out and do this, which I think makes it look more recognizable on how to do it. Not that you can't do it the other way. All right, so then, well, here we are again, anti-deriving u squared for the 4th time. So I'm just going to save us some trouble of reflecting back or using our brain at all. It's just going to be exactly what we've done over and over and over and over again. We have, oh, whoa, what am I doing? That's a lie. Plus e. Okay, so we have this, and then in place of u, I'm going to go ahead and plug in my cosine. So I have -1/3 cosine cubed x, if you want to write it that way, or you can put the cosine x entirely in parentheses and cube it. Just make sure the -1/3 is not in parentheses. Plus e. Any questions on that? So in some ways, this is a lot of new stuff. In some ways, this is just combining old things. Okay, because you're getting your derivative practice, so that's great. You're not going to lose that skill because that won't go away. I mean, it's going to be on your AP test. But then also we're integrating practice and we're putting it together to do these substitution problems. Okay. What time we got? 6 minutes left.
Don't forget to spray test this time like we usually do.
Okay, we're going to do this one definite integral, and then I'm going to spray test, and we'll be good to go. Okay. So I love this because it is telling me how to do u substitution with definite integrals. And so even though the definition itself or the theorem looks crazy, a lot of times it does, it's given us the same thing that we did before with our u substitution and this. That's not anything new. The difference is, look at your limits of integration. They are no longer a and b. They are plug in a and plug in b. Okay, that's important because I can't integrate and have all this u stuff and be plugging in x values if I don't have x's. So if you want to put things back and make everything x's, then you can have your limits of integration be x's. But if you want to save yourself some trouble and not put everything back and leave it as u, you just plug in u's. Okay, so that's what we're going to do. So this problem looks a little bit familiar. So let's go ahead and find our u. Let u equal x squared plus 1 as we had before. Du is still 2x dx. However, I need it to be x dx. So I am going to then multiply both sides by 1/2 or divide both sides by 2, whichever way your brain does it, so that it matches. So now I have the integral, the 1/2 I'm pulling out front, of u cubed du. Okay. Now I'm not putting my limits of integration because, again, that's mixing u's and x's. Okay, 0 and 1 are x values. So if I'm going to have an integral with just u's, I need u values to plug in. So what I love about this is I have x equals 1 and x equals 0. And I can change them to be u values because I have an equation for u. So in order to find a u limit of integration, I can plug in 1. So that top limit of integration changes from 1 as an x value to 2 as a u value. And then I'll plug in 0, which means my 0x limit of integration changes to be a 1. Here's why that's easy, is watch how we do this problem, and it saves us a step. All right, I keep my 1/2. The antiderivative of u cubed is what? 1/4 u to the 4th. I don't have a plus c because it's definite integral. I'm evaluating it from 1 to 2. You do not have to plug u back in as an x value. Now that you have u values to plug in, there's no reason to go backwards at all. We don't need the x at all. We've already done the work with the x. It's over. Okay, so I will now have 1/8 plug in 2 minus 1/8 plug in 1. If you remember, we plug in the top minus plug in the bottom. 2 to the 4th is 2, 4, 8, 16. 16 times 1/8 is 2 minus 1/8. So then we have 16/8 minus 1/8, so we have 15/8. So the biggest difference, one, you have to find your new limits of integration. New limits. 2, you don't have to put x back in for u. Okay? Now, here's the thing. If you would like to do that, I'm going to spray this as I talk about it.